So let's look at one more process then that we have already looked at before in terms of spatial variation of the basic state and how that could interact with convection and the related waves. We had written the ray path equations essentially for zonal, meridional, and vertical with the background state this way. And what happened there? Okay, the energy density equation becomes important in this case because we are essentially trying to explain again the interaction of convection and the waves and the circulation. So the energy density is also related to the background state, and we did some experiments where we had small scale and large scale forcing with the temporal structure, and we argued that even in this case the full nonlinear model that was used here with the background state produced, with realistic background state, produced perturbation kinetic energy that is similar to what we had done theoretically in terms of the negative and positive stretching du dx less than 0 and so on. So we had regions along the longitude in the deep tropics where energy accumulation or wave trapping was possible, and it was similar for both small scale and large scale forcing, except the energy amplitude was obviously different. The perturbation kinetic energy is much larger when you have large scale forcing, but it's happening at essentially the same place depending on the stretching, or the u bar x being less than 0. So less than 0, less than 0, less than 0, right? Does that also work in the case of convective processes? We had done the hypothetical upper tropospheric zonal wind field with the easterlies and the westerly duct, and again the easterlies, and the divergence is shown here with the realistic mid-latitude westerlies, and we had looked at how the wave trapping and the meridional extent of the influence was affected by the basic state. So we had the westerly duct extending the influence of the waves to higher latitudes, whereas the easterly regime, the basic state was trapped. So here is the initial short Rossby wave and mixed Rossby gravity wave getting trapped and extending the influence to higher latitudes, whereas here it was more trapped and it had to come around and then extend again to the high latitudes in the westerly duct region. Okay, so that same idea can be extended here to actually link also the generation of cyclones, hurricanes, and typhoons to convective activity. It's been known for long that, well, since Gray did it in the 1960s, Bill Gray did it in the 1960s, and then various other people, that there are relations between, for example, phases of the MJO, easterly waves coming off of West Africa onto the Atlantic, and so on, that there is a relation between some features of the atmosphere like the mid-level humidity, vertical shear, vertical velocity, and so on, to cyclogenesis, which means the number of storms that are created doesn't necessarily go from the formation of the storm all the way to the cyclone or hurricane and typhoon. It's just that you can find the generation regions of the cyclones and look at basic states and relate various parameters like verticity, vertical shear, mid-level humidity, and vertical motion to cyclogenesis. Okay, the idea is extended here to say that if you look at the mean sea level pressure and the surface winds, and then look at the variations of the zonal wind for June, July, August, September, which is typically the cyclone and the hurricane and typhoon season. Is it? Yes? No? well, the hurricane season goes all the way to November, and the typhoon season also, but the monsoon cyclone season in the Indian Ocean has a pre-monsoon and a post-monsoon season because the shear changes. Mostly we are focusing on the northern hemisphere, but nonetheless, if you look at the zonal winds at 10 north and 20 north, and look at the number of cyclones in terms of total storms and those that become strong category cyclones, you can see that in the Indian Ocean region there are relatively few numbers compared to the Pacific and the Atlantic. And this is for this period here. The number of typhoons that go from tropical storm to categories of typhoons is almost 50%, whereas in the Atlantic that number tends to be much smaller. But what is common to all these is these all happen in the region of what we called negative stretching. So du bar dx is negative, right? If you go in the x direction, u bar is decreasing here, decreasing here. Okay, so this is something to consider in the case of waves and so on. So cyclogenesis due to zonal variation of the zonal velocity may be as important in the atmosphere as the more familiar growth of perturbations in shear, and likely to be complementary. So the idea proposed by Ferrell and Watterson, and then later on by Peter Webster himself and others, Adam Sobel and so on, was that if we looked at this equation, then it's not just the cyclogenesis kind of parameter indices created by Kerry Emanuel, etc., but this idea of the zonal stretching and the trapping of the waves and accumulation of energy also seems to be consistent with the cyclogenesis. So if you look again at the vorticity equation, you can then go on to the generation of perturbation kinetic energy, right? Where does it come from? It is related to the background shear or the zonal stretching that we talked about. In this case, the perturbation kinetic energy is just u prime squared plus v prime squared divided by 2, which is a deviation from the basic state. Okay, so this is a third way of explaining the wave and dynamic connections in the context of convection, which was tried in Vichy and Sisk, both of which have limitations. And this is a third way where now it is showing the propagation, so broader scale here, weaker. So this is changes in the structure of a moving vortex migrating to the west as a function of time relative to a constant 850 hectopascal climatological stretching deformation given by about minus 0.8 times 0 to 6 per second. Actually it's 0.6 per second. A typical value of JJ over the Atlantic Ocean. In the Atlantic Ocean, the easterly waves coming off of the West Africa are typically associated with generation of tropical depressions and tropical storms that end up becoming hurricanes in many cases. So you can see that as they propagate westward, there is accumulation and latitudinal expansion of the influence with the speed up because of the vertical stretching of the vortex. So relative vorticity is changed because of this, and the cyclonic circulation in the northern hemisphere is going to give you vertical motion which can move moisture from the surface to the free troposphere that you need for the explanations we are looking for. Okay, let me do this in the next podcast because we are already at about 10 minutes. So maybe I'm not doing as good a job as an atmospheric dynamics person would do, but I'm just trying to lead you to the physics again. So what we are doing again here is we explained Vichy and Sisk, and we are adding the third idea from Peter that the differences in wave speeds and circulation associated with convection is still related to the idea we discussed before in terms of the influence of the basic state on the waves, where we had also introduced the wave stretching idea for explaining the meridional influence or the latitudinal influence of the waves, right? So we are still along the same processes